give check the message.
Okay, so we have done last class the introduction of derivative, and we found the formula for first derivative, which is of the approximation order of h, right? Order of approximation h. So what we plan to do we want to solve the we started to talk about differential equation. And we found that we told that the differential equation sometimes it won't be possible to get analytical solution. In that case, we have to go for numerical solution. When you go to numerical solution, everything was down to algebraic system. Remember that when you go for a numerical system, that's why I taught the algebraic system first. So whatever we do numerical system, finally it will boil down to algebraic system. That's the important part. And since it is algebraic system, that means the differential form, the derivative, first derivative, second derivative, all will be the algebraic, and we have shown that how dy dx can be written delta y delta x. As I said that dy dx is nothing but the definition of dy dx is limit delta x tending to 0, delta y by delta x. Delta by delta x is algebraic quantity. When you put limit delta x tending to 0, this entire quantity is no more algebraic, it is differential form. Okay. So this part actually I told that if you can work on this part, that will be pretty amazing. And delta y by delta x, it looks like that is a linear curve, we can approximate, but from the Taylor series we can actually get even higher order formula. It is not a linear formula. If you actually talk about dy dx, which is nothing but delta, we can say approximated, which is nothing but the order of h. Okay, if h is a 0.1 with a big amount of error, the distance between the grid point. So you talk about the grid point. These are the grid points, and this ith point is I plus 1th point, and this is I minus 1th point. Okay, if the grid size is large, that is h, and in that case dy dx, when you have the formula for from the Taylor series, you remember that you have truncated, once you truncate, then the term where you truncate, that's the maximum term. We have shown that because h is actually the entire domain is 0 to 1. Remember that. And h is always fraction. That means h is greater than h square, which is greater than h cube, and so on. So of course, which is the first term where you truncate, that's the maximum number of term because h is always less than 1. Because the domain is 0 to 1, how h can be bigger than 1? So if h is always less than 1, so this is the way it goes, and once the term when you truncate, that will give the maximum magnitude of the error. Okay, so in that case, we found this is the formula if you actually use for dy dx, which will give the error h. So but we don't want to increase number of bit size, because if we increase number of bit size, what actually happens? It will increase the computational cost. So in that case, the question comes: if you have the less number of bits, can you have the higher order approximation? The answer is yes, and let's look at it. So once you talk about the higher order formula, for Taylor series we need more information or grid points. Remember that when you did fxi plus 1, which is f of xi plus h f prime xi h square by 2 factorial f double prime xi, and you truncate it. So order of it is a square, and derivative is order of h. So if you see that you need one base point here, xi plus 1, xi. So one formula is sufficient. But thing is that you want to have a higher approximation. That means we want the derivative formula itself is having h square. Why advantage is h square? Because order of h is 0.1. Then order of h square is, what is that? 0.01. So this is a better approximated formula. The accuracy is 0.01 is much better approximated formula than order of h. Right? Accuracy is 0.01 and accuracy is 0.1. Right? So this is a very critical issue. So if you want to have order of error h square, that means we need to have h cube type of formula here. Because if you have Taylor series h cube, then only derivative you can get order of h square. Right? So if you write f of xi plus 1, which is f of xi plus h f prime xi plus h square by 2 factorial f double prime xi plus h cube by 3 factorial f triple prime xi. And if you truncate it, the order of it is h cube. Remember that in the formula we have 3 terms. But you have to find out f prime xi. That means this term has to be eliminated. Otherwise, derivative formula cannot have a double derivative in the term. It's a problem. Right? When you have formula, see, this formula gave you what? F prime xi equals to f of xi plus 1 minus f of xi by h. Order of error is h because we divided every term by h. There is no issue here, it is straightforward. But you cannot do the same thing here. If you truncate here, then this term is remaining. How to eliminate this term? How to eliminate? See, if you have the formula, if you divide by h, what will actually happen? F of xi plus 1 minus of f of xi minus h by 2 factorial f double prime xi by h is f prime x. It is wrong formula. We cannot have that. We don't have double prime. How to eliminate that? Pardon? No, I want to go forward. So in that way, so this will lead to the two situations. One is called the forward difference formula. One is the backward difference formula. Another determines central difference formula. So now the situation is, to eliminate that, we need to have another equation. So I can travel in the forward direction. Okay? Or I can travel in the backward direction. So if I derive a formula which is based on the forward direction, that means if my base point is I am taking I plus 1, I plus 2, I plus 3, like that. The information at the forward direction. So that means here if you look at f prime xi requires information of the function value at the ith point and I plus 1th point. Similarly, we are going to have a formula of f prime xi where we need information ith point, I plus 1th point, I plus 2th point. That means I am going to the forward direction. So this kind of formulas are known as forward difference formula. This type of formula is known as forward difference formula. So next available function point is f of x I plus 2 equals to f of xi plus, we have to always write the data in respect to the base point, in the base point, plus everybody is actually doing something but nobody is giving correct answer. F of xi plus 2 equals to f of xi plus, what's the distance? What's the distance? 2h f prime xi plus 2h whole square by 2 factorial f double prime xi order h2 again. Okay? So now if you look at, this is h square by 2 factorial, this is 4h square by 2 factorial. So you have to multiply something such that if you subtract these two terms will go. What you have to multiply with? What you have to multiply with? So this second equation is the first equation, the second equation. What I can do, if I multiply second equation into 1 by 4 and subtract the first equation, can I get it? Yes or no? What finally you got? F prime of xi. Finally f prime of xi equals to f prime of xi equals to finally f prime of xi equals to f prime of xi equals to f prime of xi equals to, it is taking so much of time. You just simple multiply by 1 by 4 and subtract. It is taking so much of time, and then finally get the f prime of xi. How much are you getting? It takes so much of time. You cannot multiply. That's the problem in the class, you know. That's a simple subtraction, multiplication you cannot do. Anybody got the answer? Could be wrong also, no problem. Multiply and subtract. Vasudha got it? How much it is? No, f prime of x I am asking for. What is that? Who can give me answer? Simple multiplication subtraction, Nikita. F prime x, you get it? No. Same, that is all copying actually. Why you are copying here? You should try to apply your brain. Don't say that you don't know 7th standard mathematics. 7th standard mathematics only. What is the problem? You cannot do the subtraction. You multiply by 1 by 4 second equation and then subtract. What is that?
f of xi plus 1.
F of xi plus 1 you will get. See, f prime of xi, what is the denominator term? H. H by 2. What else you are talking? H by 2 or something you are saying? What is that? What are you doing actually? I don't know. I am surprised that nobody can give me an answer. Anybody can give an answer? Yes, last bench. fxi plus 2, no. Minus f of xi plus 2 plus 4f xi plus 4f what? You are giving half answer. Sometimes your mouth will not be fully open. You just say 4f. Bracket is not mentioned. 4f is got it. And then minus 3 of f xi. The simple thing took so much of time, huh? No, you didn't tell me the answer like this. People are saying that 2. Why is 2 here? No 2 is coming here. And 2h is there. How can you get 2 in the numerator part? Okay. What's the order of error for this formula? Order of error is? What is that? H square. That means you can see that if you have the 3-point formula, it's called 3-point formula. If you take the 3-point formula, then actually what you can get, we can get higher approximation. We can get higher approximation. Similarly, if you want to have order of error h cube as an approximation formula, you can take another term, f of xi plus 3. That could be the possible exam question. I can ask you a question. What will be the formula, find difference formula for the first derivative with order of error h cube? How to derive it in that case? If more and more approximation means more and more Taylor series formula you need to have to get the approximation. The funda is clear? Yes or no? Funda is clear? Nikita? Okay. So, similarly, you can actually have the backward difference formula. So, for the backward difference formula, what actually I am not going to this backward difference formula. We can, backward difference means you take I minus 1, I minus 2, I minus 3. So, base point will be I. And your formula will be using xi minus 1, xi minus 2, x minus 0. You are going to backward direction. So, whatever formula we will be using all in the backward direction. All in the backward direction. So, that will be the backward difference formula. That is the backward difference formula. Now we see that for derivative, first derivative, you need to have the two function evaluations to get order of approximation h. Three function evaluations to get the order of approximation h square. Same thing will happen for the backward difference formula. Same thing will happen for the backward difference formula. What will happen to the central difference formula? Will that be more computationally expensive? What I am saying that computational cost is very important for numerical calculation. For the first derivative, you see the computational cost is two function evaluations. Here the computational cost is three function evaluations. Will it be more function evaluations to get the same approximation, or the same number of function evaluations, or the less number of function evaluations? What is your guess? Huh?
I plus
Less. How? Okay, we'll see that. Less could be the right answer, but we'll see that why central difference formula will be computationally efficient. Computationally efficient. We will see next that one. So we have done here. So I will come back to central difference formula before going to that. We'll talk about the second order second derivative. We'll talk about the second derivative. How the second derivative formula will be. How to obtain second derivative formula. For second derivative formula, you can see that only one equation is not sufficient. Okay? We need to, because the second derivative formula, if you see that, you need to consider up to f double. And in that case, f prime x is already there. So you have to eliminate. You cannot have a formula because is whatever derivative formula, remember that it is an algebraic expression. Algebraic expression means some function evaluation divided by the width of this grid point. That's the algebraic formula. In that formula, there should not be any f prime and double prime. Then your purpose is gone. So, what we have to do for the second derivative formula, only single formula cannot be applied. You please write down these kind of things. I am telling you, you are so unfortunate. I am not unfortunate, you are unfortunate because the way I am teaching, no books have this way explanation. You are unfortunate because you are not writing. You are unfortunate. Anyway, I will not tell you what to write along because I know the knowledge. For me, my knowledge is there. Whether you want to take my knowledge, your problem, not my problem. Okay. So, let's look at, from here it is quite obvious that for second order derivative formula, we need to have two function evaluations because you need to eliminate f prime x. You need to eliminate f prime x. So, let's look at the two formula, which is first formula is f of x I plus 1 equals to f of x I h f prime x I h square by 2 factorial f double prime x I plus h order h. I will not write because you know the formula. Because if you truncate it, maximum value is h2. That's the maximum value of it. This formula itself will not be adequate because you cannot get f double prime x I in terms of function evaluations because f prime x I is already there. We have to eliminate f prime x I like the previous situation. And we are going for the forward difference formula. So, f of xi plus 2 is f of xi 2h prime xi plus 2h whole square by 2 factorial f double prime xi order of h cube. Sometimes you may say order of 2h cube. Doesn't matter, I am interested in the h cube. How much is the fraction? If you multiply by 5, 2 doesn't matter. I want the error. Okay. Unless it is multiplied by 10, I am not going for 10. Otherwise, the order is 0.01, 0.05 and so on. Like that, some order of magnitude estimate. So now see that we have to eliminate this. So, what is the situation? How will you do the thing? If you divide by second equation by 2 and subtract 1 from there, you can get a double prime formula. What is my double prime formula then? What is my second derivative formula? What is my second derivative formula? I told you how to do it. It's very simple, like the previous one. What is my second derivative formula? Second derivative formula. xi. Yes, any answers? F of xi plus 2 minus plus by order of error. What is that? Order of error? H square, huh? H cube, huh? He said H cube. Amit, H cube, huh? How it is H cube? Can you tell me what is H cube? Amit, why it is H square? Divided by what? Did you do the calculation? That's what. Without doing, don't open your mouth, okay? Because it is not child's play. It is mathematics. Order of error what? Ramanjan. Order of error H cube by H square. It's quite obvious. I am giving the answer here. H square is there. It is actually takes only half a second to get the answer. Order of error is H. So this formula f prime xi, which is f of xi plus 1 minus of f of xi by h, order of error h, these two are compatible formula. That means if you get this formula and this formula, what actually happens? This has got more accuracy than this formula. That means these two formulas cannot be used together, because if you have derivative, one approximation, second derivative of the same approximation required. Otherwise, what actually happening? You will be having error in the problem, because whatever approximation you actually see, maybe you are giving more importance of second derivative or more importance of first derivative. In that case, your energy balance or the mass balance or the momentum balance may not be satisfied correctly. Right? So that is a very important situation. So when we use derivative formula, we have to be very careful. That's the part none of the books, none of the teachers in the different colleges or different places, they emphasize here. This point is very, very important. The formula is very, very important. Order of h. If I use order of h, I have to use this formula. Otherwise, if I use order of h square, I need to have h square formula here. I need to have h square formula. What is h square formula? What is h square formula? That means you need to have up to h to the power 4 here. Up to h to the power 4. Okay? And then if you divide by h square, then only you get order of h square. What will be the formula? If I have order of h square, can you derive and tell me what is the formula for order? So that means if I want to use this formula, the first derivative, second derivative should also have, for this compatible, this for compatibility criteria, f double prime xi, I need to have order of h square. I need to have order of h square. What is the formula for the order of h square? Possible exam question. I will not tell you. That is a possible exam question. And I can give you the answer. Minus f of xi plus 3 plus 4f xi plus 2 minus 5xi plus 1 plus 2 of fxi divided by h square. Minus f of xi plus 3 plus 4 xi plus 2 minus 5xi plus 1 plus 2fxi. So there are 4 function evaluations. So 3 function evaluations for the first derivative, 4 functions for the second derivative. And in that case, these two formulas are compatible. So when you use this formula for the second derivative, never ever use the first derivative formula with that, because in that case what actually happening, you are giving more accuracy for the first derivative and less accuracy for the second derivative. Your results may be erroneous. You may get wrong results. So this part is very, very important. Please write down this part. This part again not there in any of the books. This kind of emphasis is not in any of the books. So I think the backward difference formula can be derived in the similar manner, and some of the derivations I will be asking in the exam. So please practice this derivation. You just like a child's play. Okay, I want to have first derivative formula order of approximate h2. What's the formula? Or order of approximate h2 equal to what's the formula? So we know the data series. We know what are the points. Forward difference means you have to go to the forward direction. Backward difference formula means you have to go to the backward direction. And next we are going to discuss about the central difference formula. And as I said here, the central difference formula is computationally efficient. We will now going to demonstrate how central difference formula is computationally efficient. So if you look at this entire spectrum of the grid, the entire spectrum of grid, you can see that forward, if you use this function evaluation in the forward direction, you get forward difference formula. If you use this backward direction function evaluation, you get the backward difference formula. You have seen the forward difference, you use the f of xi plus 1, x of I plus 2, xi plus 3 and so on. Backward difference, same way you can derive xi minus 1, xi minus 2 and so on. Central difference formula, what it does, this is, it considered, this is the mirror. That means, if I take this point, the image is this one. If I take this point, image is this one. So, it will take the point and its reflection. It will take a point and reflection. And that's the point, that's called central difference formula, CD. So, you take this two, you take this two. So, as a pair it will appear. So, if I take xi plus 1, I have to take xi minus 1. If I take xi plus 1, I plus 2, I have to take I minus 1, I minus 2. If I take I plus 1, I plus 2, I plus 3, I have to take I minus 1, I minus 2, I minus 3. So, in that case, your hands are tied because minimum you have to use 2 Taylor series, the central difference formula. But I will show, I will demonstrate why it is so advantageous. So, let's look at f of xi plus 1 formula, which is f of xi. So it is, I am talking about central difference plus h f prime xi plus h square by 2 factorial f double prime xi order h cube. One function evaluation. As I say, central difference formula, I have to take the function and image. Image is f of xi minus 1, which is f of xi minus h of f prime xi plus h square by 2 factorial f double prime xi. If I add it up, you won't get f prime, you will get double prime. So, you have to subtract. And what actually happens? This will get cut. Right? So what do you get? F of xi plus 1 minus f of xi minus 1. Then equals to, this is also cut. 2h f prime xi. I come here, the question mark for you. F prime xi, which is f of xi plus 1 minus f of xi minus 1 by 2h. What is the order of approximation? Why? H square by h is h, no? So, that means Amit is confused if I fool you. I am fooling you actually here. If I actually try to fool you, you fool. Of course I can argue that h square by h is h. Is it correct? Of course not, because they are cancelling. So, this term, so if you look at the series here, this contribution is not there. So, in that case, next term you have to take, which is h cube by 3 factorial, f double prime xi. It is minus h cube by 3 factorial, f triple prime xi. And if you add it up, it is minus minus, so it is nothing but, this will be h cube by 3 factorial into 2 into f double prime xi. So, it is order of error h cube and it is h square. Anybody can do mistakes here. Now we can see that I said that compression That means to get order of a raised square formula, you need to have only 2 function evaluation. Here, we need to have 3 function evaluations. So central difference formula is computationally more efficient as it requires less number of function evaluation for the first derivative. If you don't write down, that's it. No books again address this kind of points. I am not saying. First number books will be all jumbled up. They will use first derivative order of a raised square, second derivative will use order of a raised and solve the problem. Many books do that. They won't even address this issue that accuracy of the formula is very, very important for particular derivative. Okay? So A prime xi part is clear. Okay? What will A double prime xi? What will A double prime xi? So now if you look at, if you use these 2 formula for A double prime xi, what you will get? A double prime xi also you can use these 2 formula, right? If you use these 2 equations, what formula you get for A double prime xi? Using these 2 equations, A double prime xi, who can give me quickly answer? Using these 2 formula, A double prime xi. Remember that you have evaluated F double prime. That means this cannot be subtracted. This will be added. So in that case, this will be gone. This will be also gone. With that, you get me the answer. What is that? F of xi. Then so many things you told. F of xi. F of xi. How many terms will be there? 3 terms are there. F of xi plus 1. Divided by order of error. So now if you look at even the second derivative formula has a 3 function evaluations. I get the order of a raised square formula of the forward difference. We can see there are 4 terms. That means for second derivative also this is computationally efficient. That means what I recommend that although it is possible to have forward difference formula, backward difference formula, although implementation wise forward difference formula, backward difference formula easy to implement, especially for the boundary conditions, but the computational cost wise central difference formula is more efficient. If you don't write, you miss the point. I am not going to repeat it also. Okay, so we'll demonstrate it for solving our problem. So if you look at, we got very cute formula for the first derivative and the second derivative for the central difference. So we have decided not to use forward difference formula or the backward difference formula. So now our part is over. We'll be now going for the pore diffusion problem, chemical reaction here. So remember that whatever we do, our job is to apply in chemical engineering. So I think we have done the chemical reaction engineering part, and we'll be doing the pore diffusion. Z equal to 0, Z equals to 1. I have a reaction nth order kinetics. That means minus dCA dt equals to Kc to the power. Minus dCA dt equal to Kc to the power. Nth order kinetics. I think now you know all kinetics. Maybe you are more knowledgeable than me. Of course, I don't know much chemical reaction engineering. Always I used to get very less grades because I never like chemical reaction. You know that because if I see chemistry, I get scared. So that's why I used to always get scared with the chemical reaction. But finally, I found that chemical reaction engineering has got a lot of tensor. So once, whenever the tensor is there, I'll be interested. So that's why I mean this is the mathematics part. If you talk about the chemistry and kinetics, I know you are much more knowledgeable than me. So what will be the pore diffusion equation? That is your part, not my part. You supply the mathematics, that is my part. That is the way this is called collaborative research. Now I am doing collaborative research what we do. Chemical reaction is science you actually give. the information to you? I will do the mathematics part. Because you know that my chemical engineering knowledge is very, very limited. I don't know much chemical, I know only mathematics, that's why I'm surviving. What is the reaction? What is the port diffusion equation? And the boundary conditions. What is the port diffusion equation? You have seen this port diffusion, right? You have done it. Port diffusion, that is done in chemical reaction engineering, right? This port diffusion problem. What is the equation? And kinetics is another order. Kinetics is another order. Amit, I guess you are the expert of chemical reaction engineering, right? Yeah, how much you got? Quizzes? 23 and all. So that means I cannot get 23 and all. I will get only 3 or maybe 0. So you are expert in chemical reaction engineering. You should tell me. What is the port diffusion equation? Vasudha? Port diffusion equation. What is the equation for the port diffusion? Yes, madam. That is the boundary condition I am talking about. I am talking about transport equation. I am talking about transport equation. Okay, what do we do? You do mass balance, right? Port diffusion, mass balance with chemical reaction. And what we do here is species transport. What is the equation for species transport? We have done mass transfer, species transport. What is the equation for species transport? Species transport. There are two species, CA and CD. If I want to talk about what is the transport equation for the species A, what should I write? No mathematics here. I am asking only chemical reaction engineering now. Now no more maths. Math part is over. No more mathematics. What is the species transport equation? The species dou CA by dou T plus V dot grad CA equals to, and here velocity is 0, there is no bulk velocity, then equals to I am surprised that so much of chemical, you will be going to the GATE exam, and these kind of problems are actually generalized in the GATE exam. Even if you are well prepared for the GATE exam, what kind of things you are not able to give anything to me. Equals to what? Species transport. What is that? It is what? See, what actually happens? A is going here, okay? B is being generated here and coming here. So what is this process in chemical engineering? A is going here, B is going here. What is this process in between here in chemical engineering? Diffusion. Right, it's called diffusion. See the situation of your knowledge. So, if diffusion occurs, what will the transport equation? What is transport your right hand side? What is transport equation? You have done it in Buzzword, light food or mass transport, BTEC level. Right hand side will be what? Right hand side will be what? See, heat transfer we had rho Cp dou T by dou T equals to K dou T by dou Z square. What will be here? Similar equation? See, so much of struggle I have to make to get this simple thing equals to dAB dou 2Ca by dou Z square. Okay. Now the situation is, this is possible if there is no reaction. But reaction is occurring. That means Ca is going out of the system. Okay. How to write the balance equation? Ca is going out of the system. What is that? How to write? So something is going out. That should be minus. Like in heat transfer, if heat is being generated, we put QT, rate of heat generation. Here it is rate of species destruction. What is the term? What is that? So many people are saying something. Vasudha, please. Minus Kca. What is the order of kinetics? Minus Kca to the opponent, and if you want to check the dimensionality, you can check the dimensionality. You can check the units, from there you can actually find it. Now what I am saying that is steady state. I will come to unsteady state part first. Second part, first part I will be doing steady state, next I will be coming to unsteady state. Okay? Steady state part. What actually happens? dAB dCA dz square, because now time dependency is not there. It becomes ordinary differential equation, which is kCA to the power. So for those kind of problems, what actually happens 0 to L, and L may not be 1. L could be 3 cm, 4 dimension, 4 cm. You cannot do finite difference method because h may be greater than 1 is a problem. So you need to do dimensional analysis. You need to do dimensional analysis. So real problem if you take, the length scale is not meeting not 0 to 1, and in that case numerical techniques cannot be implemented. It will be a serious problem. And in that case, what actually happens? We do dimensionless. So CA bar we can write as CA by CA0. Difference concentration. Z bar, dimensionless variable, we define as Z by L. What else is there? Nothing else. So my equation is DAB d2 CA by dz square equals to K CA to the power n. So you replace CA by CA bar, Z by Z bar. What will happen? How to replace? DAB dBz dCA dz equals to KCA to the power n. Next step is DAB dBz bar dCA bar dCA bar dz bar dz bar dz bar dz equals to KCA to the power n. Did you understand this step? The usual step we do it. This is calculus. Z bar, whatever you do here should go back to the previous step. You are getting back, of course. Z bar gets cancelled, CA bar gets cancelled, so you get the previous step. So this step is very close. Many people do the mistake. Understood the step, right? So now you tell me the answer. What Faraday equation you are getting? What's the Faraday equation here? What's the Faraday equation you are getting? What's the final equation you are getting? So what I'm saying here, you will finally get d2CA bar by dz square bar square minus beta CA to the power equal to 0. What is this beta? What is this beta? What is this beta? Beta equals to? What is this beta? You tell me the correct answer. Beta equals to K. Remember that CA to the power n should be substituted by CA bar, CA bar into CA0 to the power n. Everywhere should be CA bar. There is no dimension quantity. Everywhere is C dimensionless quantity. So in that case, you can say Z bar is varying between 0 to 1, right? In that case, you can apply finite difference peacefully because your bit size will be less than 1, and you can apply all this formula peacefully. Otherwise, the problem. I think this kind of things should have been done in chemical engineering. I am not supposed to teach this part. This should have been done. This is not my territory. This is not my subject. Do the dimensional analysis. This has been done in chemical engineering. I am doing here maths. What is beta? Then, what is beta? Yes, madam. K into L square CA naught n minus 1, sure, yes, divided by what is the dimension of this? What is the dimension of this? So we can write this as K CA0 to the power n minus 1 DAB by L square. What's the unit of K? Unit of K is what? KCA to the power N. C is moles per meter cube per second. It is moles to the power N. What is the unit of K? Okay, fine. What is beta unit? What is that? No dimension. What is called actually? In chemical reaction, some term is there for this. What is this called? In chemical reaction, we have done chemical reactor theory, so you should be knowing this term. What is this called? What is that? Volumetric modulus. This is called as volumetric modulus. Okay, so this is my governing equation. Now let's talk about the boundary condition. Let's talk about the boundary condition. What is the boundary condition? Boundary condition for this problem, what you can think about? At z equals to 0, Ca equals to what? Ca 0. At z equals to L, dAb, dCa, dz, I am writing more generalized formula, which is K Ca minus Ca infinity. That means the mass transfer coefficient. Whatever is going here by diffusion process, it is caused by mass transfer. It's a pore. It's a pore. It has got. It has. See, if it is impermeable, you can whatever you are saying correct. dCa, dz equal to 0. But it's a pore. Pore means it will go further by mass transfer. So you need to have mass transfer coefficient. So you need to apply all chemical concept. What are the dimensionless equations for the boundary conditions? What are the dimensionless equations for the boundary conditions? Next question is about dimension. So I Z at Z bar equals to 0. What do you get? Ca bar equals to 1. At Z 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 bar equals to 1, how much you will get? I will write something dCa bar by dZ bar plus alpha 0 Ca bar equals to alpha 1. Alpha 0, alpha 1 you can determine, right? And it should be dimensionless quantity. Maybe next class you can give me the answer. So next class I will be starting from here and solve this our classical chemical reaction problem, steady state problem by finite difference method. Next topic will be unsteady state problem we will solve, and that will be the end of our syllabus. Thanks for coming.